In this 9th lecture of special relativity, we discuss how to relate velocities measured in two different inertial frames. In the previous lecture, we have seen that distances and time intervals are no more absolute concepts when assuming the principle of constancy of the speed of light. To observe how velocities relate between frames when the principle of the speed of light is taken into account, we considered the thought experiment of a race between a moving ball and a photon, bouncing back at a mirror. Firstly, we observed the race in the train coach frame, where the coach, where the experiment is conducted, does not move. Then the same race is observed in the station frame, where the train coach is moving with constant velocity. Also in this second frame, we were able to compute the fraction of the coach length, A, that the ball travels before it meets the photon again. As fraction of lengths are independent on the inertial frames used to measure them, we were able to relate the velocity of the ball measured in the train frame to the one measured in the station frame, all as a function of the velocity between the two frames. The formula that we obtain is general and tends to the velocity addition in classical mechanics, that is the one following Galilean transformations, for velocity between the frames that are negligible compared to the light speed. We finally discussed an example of this formula.